Good afternoon. So the third session after lunch, and I won't take long, so maybe 15 to 20 minutes, and it won't be overly technical like the excellent sessions from morning. So we'll keep this light. And so we already talked about accelerated compute. This would more be about learning the concepts and fundamentals to reach and work, identify similar problems and start solving them. How to start that, right? So we will be discussing something, and maybe we'll be introducing some production hardware that we have deployed here, and how we can use that to learn some of the basic concepts and strengthen some of the fundamentals, right? And then work towards the bigger problems. We have been talking about accelerated compute and accelerated infrastructure for the last 4 days, right? So how I would define is using specialized hardware, specialized instruction sets, specialized extensions to perform specific workloads, right? Tuned to perform those workloads more efficiently. And this can be anything, whatever we call it, XPUs, DPUs, GPUs, ASIC, TPUs, right? So for any kind of workload, if you're using some specialized hardware, we're terming it as accelerated compute. Benefits definitely, like it was highlighted, the scale that was mentioned by Priyanka earlier, as well as Shrijit and Satanand in the earlier talk, right? The scale of computation that's required for the AI/ML clusters, for the networking around it, for the infrastructure around it, is staggering. So definitely we need that scale, we need that performance, we need lower power, right? So accelerated compute is about meeting all those benefits. And just to give a very simple traditional example, right? So if I just take 100 Gbps or 30 Mbps of IPsec traffic that needs to be processed, so you have only an average of roughly 33 nanoseconds per packet to process per packet. In that, just to do IPsec, you need to process multiple levels of headers. You need to do L2 header, you need to do L3 header, IPsec header, inner header, UDP header. Apart from that, you also need to do cryptography over the whole payload, right? So if you have 100 Gbps, you are technically touching every byte to decrypt or encrypt in 1 second. Like 100 GBs you are processing in 1 second, right? So this is some good exercise to take up on what would be the different schemes that you can utilize. And one example that you can run on the Opteon that will be deployed in your lab would be VPP. So VPP is a good example to start with. And you can see how with VPP you are able to manage to do 30 Mbps of IPsec traffic, that you can run that example. And then you can gather statistics, right? And you can see what all does VPP use, how does it use burst processing, how does it use the cache locality, how is it pipelining the nodes, right? How is it using the SIMD instructions to process the header fields, the different hardware accelerations like Intel QAP and Marvell Crypto and Marvell Inline IPsec is used, right? So these are things that you can actually try out and you can actually see. Traditionally, if you just write a simple program just to compute the UDP checksum, right? You can see whether you can do it in 33 nanosecond or not, right? And why it's important to actually accelerate those workloads. And that brings us to the data acceleration and offload lab. So this is currently like we have managed over the last 3 to 4 days, thanks to Shehbaz here and Satish and a lot of the team who have spent a few nights in your data center to put up the setups and configure them for this workshop. So because we had a long weekend, a long holiday last week of December, we started this on 2nd, and over the first 3 days we were able to set up some Opteon 10 DPUs. So these Opteon 10 DPUs have specialized workload accelerations that you can utilize. And it's actually, the idea is to fuel the innovation using this and build up collaboration between the industry and academia. right? And this is going to be open access. So apart from the IIT Hyderabad students, even students of other institutes would be able to use this, right? Once it's live, maybe in 1 or 2 months. So how does Octeon look like? So you have some general purpose cores, like around 24 ARM cores, which are N2 cores. These are powerful enough. There are enough experiments that you can do just using the ARM cores, right? So there are neon instructions. You can exercise the SIMD instructions there. You can exercise the ARM V8 crypto instructions. Right? That's on the ARM compute side. You have a very efficient and powerful packet parser that can parse your packet headers up to multiple levels. And then you have hardware accelerators for flow ordering. You have inline IPsec, reassembly, cryptography, symmetric RSA, like symmetric asymmetric cryptography. It supports virtualized accelerators, right? And traffic management and QoS. So there was one question that Shrijit asked, which was virtual output queues, right? You can exercise that. And it also supports a 5-level hierarchical scheduler, so you can actually understand the QoS concepts, the shaping, scheduling, how packets go out, how they need to schedule. That in itself is a massive problem to solve, the full flow control. Okay. So apart from the hardware, I think the bigger effort that has gone on from Marvell for this lab is open sourcing what we call the DAO solution framework. Right? So this is an open source framework that we have hosted on GitHub, and it enables development of solutions. So there are a lot of examples, there are a lot of instructions that you can actually use it, and then you can modify those instructions to take them forward, those solutions to actually take them forward. Okay, I think I had some animations. I didn't realize that I had converted this into a video. So there are, I already described the features that are there, and there are some or the other software to exercise all those features. You can exercise those features through DPDK, through VPP, OVS, OpenSSL. And apart from that, we also have some cloud native solutions that will be available in DAO, as Cilium and Calico. You can have solutions designed around it as well. And there are a lot of tools to build your own applications, and there are help documents that are available at GitHub. So today we'll be covering some of this. So we'll be going through VPP, OpenSSL, and AIML, and we'll do some hands-on on this. And then the idea is that you can then carry forward this approach. So yeah, this is something that's the idea behind this lab. The first is to learn the concepts, build up your fundamentals. Second is create some real world solutions, some proof of concepts, learn by doing something, right? And then you lead. You try to move to the next level and try to see what is required for tomorrow and the day after, right? So learning, like we already talked, there are a lot of concepts that you can learn using the lab, like cryptography, pipelining, protocol offloads, workload accelerations, SIMD instruction sets, right? And the idea, like some of the data that was shown earlier, what's the latency across PCI, what's the latency across CXL links, what's the access latency through caches, what is the access latency if you are using some CXL extenders. So all those kind of experiments is what you can learn, you can perform, and you can gather those benchmarks, get an idea of how practically it works, right? And then it's something that you can do. You can build a lot of real world solutions, right? So Octeon, how many of you have used Octeon other than my team? Yeah. So anybody who has used Octeon? How about, do you think, indirectly, do you think, have you used Octeon? Or do you use it? Okay, I think all of you might have used Octeon today, right? So if you're using your 5G network or your 4G network, your calls might be passing through at least, it will be passing through some Octeon, right? Whether you're on any of the networks in India. If you are using some SSL websites or something, there's a high chance that there will be some or the other Marvell crypto block over there that will be doing your RSA or some other asymmetric operations. Right? So this is widely deployed not only in the wireless infrastructure around the world, whether it's 5G, L2 or 5G transport, or whether it is enterprise level IDS or routers, traffic generators. You can easily build these applications. Right now India is importing most of its network hardware, right? The routers, switches, it's all imported. It's not so difficult to build it. These are the process that's used to build those. You can take an attempt. There can be a lot of startups that can come in these areas, right? And it's open to explore. There are a lot of base software that's already available that is used in routers in production, like VPP, OVS, VPP. You can experiment with some of those, right? And one thing that is always missing is like one of the challenges we have is how to generate 100 Gbps of IPsec, 100 Mbps of IPsec, right? That is traffic generators. And there are very few custom solutions that are also limited. Like if you have to generate TCP traffic today, 100 Mbps, there are only one or two IXIA solutions that are available that are prohibitively costly, and you can always build up some solution using these processes to come up with those kind of simple solutions. Okay, I won't call it simple, but yeah, it would be easily doable. And then, of course, third is like innovate, right? How do you shape the future of technology? All the areas that we are talking about, right? So how do you start coming up with similar problems? So the idea is like if you are actually doing 100 Gbps of IPsec, what should it take to do, let's say, 1.6 terabit of IPsec or 800 Gbps of IPsec? What is a better protocol than IPsec for different use cases? Do you even need IPsec? How do you do security if packets are encrypted? There are a lot of different problems that are to be looked at. Whether homomorphic is the right way to go, or are there any better approaches to compute on encrypted data? There are a lot of questions that you can ask, right? And that's what we would like to fuel, right? So over the next 2 to 3 hours, we'll be doing some hands-on, and the idea is that you get some flavor of the hardware. You try out some of those exercises now. We have very little time to run through depth of each of those, but the idea is that we'll give you an overview of how to run. You'll be able to run some examples today in the lab, and then you can follow up at leisure, right? You'll have the setups in your department. You can deploy your code and you can run. Right? So yeah, that's all I had for this session. So how many of you are interested in doing the lab today? Okay, great, good. So we will have the lab from 4 o'clock. We have a discussion planned right now.